right, well, we're going to continue on. We're on lesson 10.2, and we're talking about a two-sample t-test for the difference of means. And I was going through a problem, and I wasn't able to finish it, but I have some data here. And what we did was we took two different cookies, and I had my students in my class take and actually find the mean and the standard deviation of Chips Ahoy cookies, all right, from our sample of all the number of chocolate chips inside them, and then a Kroger Chipmates cookie that we took and did the same here. We found the difference between these two means. We got a difference of 1.236. And so we're going to do a statistical test to see, is there what is the confidence interval, all right, of the true difference in means of those chocolate chip cookies. So first off, what is the shape? So if we were to complete this process many times and create a dot plot, we would have the sampling distribution of the difference in means. Describe the shape, center, and spread of this sampling distribution. Well, first off, I'm assuming that the distribution will be things. So if we had all of this right here, we're just going to say I only had n equaling 17, all right, for both of these values. So technically, we can't use the central limit theorem here, but if when I took the sample for each one, we found that for our 1 values, we found there is no, for our sample, uh, for um, for the Chips Ahoy, there were no strong skews or outliers for that one. Strong skews or outliers. All right, skews or outliers in the data. Um, and also same thing for the sample for the chipmate. All right. And so no strong skews or outliers for that as well. Strong skews or outliers in that sample as well. And since there is no strong skews or outliers for each one of these, we're going to just say that it could be approximately normal. Okay, all right, approximately normal is the shape of this sampling distribution of the difference in that. The center, well, if we have this, we take x1 minus x2. All right, we're just going to assume that that is going to equal this 1.236. Our spread is we're going to find the variance of each one of these. So we're going to take our standard deviation. We're going to take 4.743. All right, and we're going to take that and divide it by, all right, our n value. In this case, we have 17. We're going to square that because we have to take our variances. We're going to take 2.575. You can see there's a smaller variance between the chipmates and then from the Chips Ahoy. We're going to take that and square it and divide that by 17 as well. And we can do this right here with the spread. I believe the 10% condition does apply because in each one of these, we get an n of 17. All right, for the Chips Ahoy. And we'll tell that one. And then right here, so Chip Ahoy, and then the chipmate. And we see that 17 was definitely less than, all right, 10% of all Chips Ahoy cookies. All right. And right here, there's definitely less than 10% of all chipmate cookies. All right, and so we can use this spread right there, even with our standard deviation. And so there is independence in doing that for this right here. In doing so, we can find out what that standard deviation is. So if you would put that into your calculator, all right, you would get a value of approximately 1.302. Okay, and so in doing this, have the conditions for constructing a confidence interval been met? I would say yes, because we did have two random samples. Samples of 17 Chips Ahoy and 17 chipmate. cookies. We also have our independence because of the 10% rule, as I stated above. So we do have independence. And we also have approximately normal. Even though we can't use a central limit theorem, we did notice that there was no strong skews or outliers in there. So because all these are met, we can perform a two-sample t interval for means. And so we have that right there. And so we're going to, for the difference in means, okay? That's what we're going to perform here. So we're going to construct a 95% confidence interval for the true difference in the mean number of chip cookies in here. So we're going to do that. And so to do that, we're going to have to figure out, okay, what is our statistic? So we're going to take x1 minus x2. And we found that value right there, which is 1.236. We're going to add and subtract our critical value there, t. We're going to then take our standard error, which we calculated to be right there. So I'll take 1.302 and put that there. Okay. We're going to find our t interval. In doing so, we have to compare our n values. Our n values are both 17. And so in doing so, we're going to pick the lesser of that. So we're going to have a degrees of freedom of 16 in order to figure that out. And so now we're going to figure out our one value. We can go onto our calculator and figure this out. If we use our TCDF, all right, and we go over here, and in our TCDF, not TCDF, but T-norm, all right, T inverse norm, we can figure that out. And I'm going to get my calculator ready. And so if we go over here, and we want to go into, or how you get there, you go second vars right there. If we go down to our inverse, all right, inverse t value, we want to find the area. So if you recall, we have our area, which is going to be 0.05, and we're actually dividing that by 2, because that's going to be the half of that area that we're using. We're going to have a degrees of freedom of 16 in this case, 16. And we're going to paste this right here. And so you can see this is our area or degrees of freedom. And if we have to enter that, all right, press enter. And that's going to come up with our value of 2. Now, this is a negative value, and we're going to use the positive 1. All right, we're going to use the positive 1 here. And so I'm just going to put this over here. So just so we know what we're looking at, we want to label that. That is going to be our area. All right, and that is our, oops, not that part. And the other part is going to be our degrees of freedom. Okay, degrees of freedom, or DF. And so we find our critical value to be 2.11. And we probably can maybe say 20 if we wanted to. All right, so we're going to take that value and we're going to go 2.120. And so there is our value. And then from here, we can go back to our calculator and we can start calculating our different values. So we have 1.236, and we can subtract the 2.120 and multiply that by 1.302 and press enter, and we get a value of negative 524, 524. And we can go and do the same. If we go second entry, you can go to the same thing, but we're going to change that minus sign into a positive sign. And so if you keep on going over, too far, we put plus there, and we get a value of 3.996. All right, so 3.996. And that appears to be our, all right, confidence level. And that's what we got there. Okay, and so um, with that, that is our confidence interval. And what do we find? Do we have evidence that there is a difference in the number of chips in there? Well, because we have this, and if we were to do a hypothesis test, we'd say, well, no difference would be 0. And so really what we found is that um, because, right, 0 is located, all right, in the interval, interval, we do not have convincing evidence that there is a difference, all right, in the average number of chips in a Ahoy versus chip stirs cookie. All right, and that's what we would say because 0 is not located because it's located right in the middle of that. Okay, well, that's what I found with mine. So there really is no difference between, yes, the name brand versus another uh, generic brand, as they would say. And so it matters how you want to spend your money. All right. Well, I hope this helps you out on how we can do our confidence intervals. I have another video on how to explain this in some other tutorials. All right. Well, good luck and God bless.